Okay, so I'm now recording this. I'm recording this session. So as I said, this is the LISA 2020 Symposium plenary session, the importance of statistics in urban planning and development. And our chair and organizer is Dr. Lubna Naz from the University of Karachi in Pakistan. And so she's working on getting her video working. There's some technical issues that she's working through. So as she's doing that, I just wanted to mention about the LISA 2020 Symposium. So this was originally scheduled to be a face-to-face symposium back in 2020, but of course, because of COVID, we put it online. And rather than have it just all condensed into 1 or 2 days, we decided to stretch it out to be once every month. And so for the next hour and a half, we'll be hearing from 3 speakers today. And there should be time for questions, and those questions and discussion will be moderated by Dr. Naz. So Lubna, are you ready? Do you want to take over and introduce the session and your speakers?
Oh yes, thank you so much, Eric. Thank you for introducing me as chair of this session. Still, I'm facing a problem to keep my camera on, but I will try to be on camera as soon as I resolve this issue. And with that, I would like to say something about this session, that what this session is about. This session is about the importance of, as you have told in your talk, that it is about introduction, that importance of statistics in urban planning and development. Why we have organized this session, basically, as we have learned, because we are working on a book, that is the edited book, which we are currently working on. In that book, we have included this chapter, which is the importance of statistics in urban planning and development. And the purpose to include this chapter was to bring to light the issues which urban population is currently facing around the world, and especially in developing countries. And we have come to know that according to one UN statistics, one estimate of the United Nations, half of the world's population lives in urban areas. And it is anticipated that it will make 2/3 by 2050. So the increase in the scale of urbanization, as you people know, comes up with multitude of challenges. For example, affordable housing, effective management of water supply and solid waste, and well-connected transportation system and environmental challenges, and the employment of the youth, especially the working age population. The use of advanced statistical techniques help the policymakers to analyze the urban planning and development related issues and find out the solutions, find out the evidence. I would say that our evidence is more appropriate to say, to find out the scientific evidence about the issues which can be used into the planning. So given with this introduction, we have 3 speakers, guest speakers, honorable guest speakers in this session, in this plenary session. The first guest speaker is Professor Carla. She is from Brazil, from UFRN Brazil University, and I would give her introduction when I will refer her for the talk. The second guest speaker is Dr. Yaqub. He is from Alanya University, Turkey. And the third speaker is Agubade. He is a senior lecturer in the Department of Urban Planning, Urban and Regional Planning, University of Lagos. So we have 3 guest speakers. So let me also tell you about the format of this session. So we will start our session with the lectures, which Professor Carla will give at first. Then we will invite Dr. Yaqub to give his talk on the title, that is the an ARDL bounds test approach to urbanization, the case of Turkey. Then we will invite our third speaker, that is Abubade Muawaya from the University of Lagos. After lectures, we will open the floor for questions and answers. And we hope that all of you will actively participate and ask questions from the guest speakers. I will moderate the session, and I would also want Professor Eric to moderate the session because there is some connectivity issue on my side. So with that, I would like to invite our first guest speaker in this session, that is Professor Carla. Her title of the talk is Climate Change, Statistics and Urban Planning. Climate Change, Statistics and Urban Planning. Professor Carla is full professor. She is full professor and the coordinator of the graduate program in applied mathematics and statistics in Brazil. So with that, Carla, it is over to you. Thank you.
And before Carla starts, I want to. Unfortunately, I have to leave before the end of this session because I teach at the top of the hour, and so I think Dr. Olawale Awe is here, and if we need a backup organizer, from Lubna, then I'll try to be that backup. But if I'm gone, then Dr. Awe can be the backup.
Okay, thank you, Eric.
No problem. Thank you.
It's over to you, Professor Carla.
Good morning. Can you all hear me well?
Yes, we can hear you, Carla. Good to
And
hear you. And good to see you. Yep.
Can you see the complete screen?
Yes. Looks great.
Yes, we can see.
Okay. So first of all, I'd like to thank you, first Lubna, for inviting me to this presentation, and also Eric for his leadership in the LISA 2020 network, Olawale for being the ambassador of the network, and all the labs and everyone that is here today. So first I'd like to share with you some pictures related to the theme of today's presentation. So this picture is from Boulder, the city of the headquarters of the LISA 2020 network. This is from 2013. This is what happened with some roads after some heavy rains. And also in 2014, this is the city that I currently live, Natal in Brazil. And we also suffered from heavy rain, and there was some damage to our streets and our population. So it's important that we can contribute and collaborate to this issue of urban planning. Statistics plays a critical role in that. The talk that I'm presenting today will be related to climate events. So we are facing extreme events, so many floods. I'm currently today in Rio, and we have a tropical cyclone close here in the ocean. So it's bringing lots of rain to the city today. So we've been facing these events. So we need to be prepared. And the LISA 2020 network, we have the potential with statistics and our knowledge to contribute to this issue and help planners to be better prepared to such events that will happen. So talking a little about myself, I'm representing here the Laboratory of Applied Statistics in Brazil. So we are part of the network since this time. I chose these years, 2013 and 2014, since it's related to the beginning of the LISA 2020 initiative. And we've been part of this initiative since the beginning of it. So here's a picture of our group. It is the last picture that we took together before the pandemic. This is from December 2019. The outline of this talk, I will talk a little bit more about the motivation, that's the climate change, that's motivation for this talk, and share some examples of the role of statistics in urban planning related to applications on fire and climate and weather simulators. And then talk about some current challenges and opportunities for collaboration within the network. So it is important for us to understand the extreme events, to be prepared and mitigate some of the events that we cannot control, and also to prepare for them. So we have been seeing that extreme events are becoming more frequent due to climate change. But the models to understand those events, they are still not good. They still have large errors. So that's the gap that you have, that you need to overcome, and where statistics can be useful. So I have some quotes from some papers that's talking about the collaboration with statisticians and climate researchers, how important it is. In one application I will talk about with you is about fire and some general statistics that we use, but I'm going to share also one application that's related to some codes that I found in the literature that's related to design of experiments. So there is little application of this tool in the area of climate research. And the statistician can contribute to better plan experiments to be used in this area. So the second case study that I'm going to talk about will handle this issue of design of experiments. The first study that I'm going to share with you is related to understanding fire patterns. But before I go into these case studies, I like to give some context of my interaction in this area. Also in 2014, I was selected to be part of a network within a project that was funded by Fulbright. They selected 20 researchers from the Americas, North America, Central America, and South America to be part of this network. And the objective of these networks is to do research related to climate change. There was researchers from different areas. I was the only statistician in this group. And there was this collaboration of all of us to propose some ideas to deal with climate change and improve the society's life. So this is one of the projects that we work regarding fire. We have researchers from different countries, from Brazil, the United States, Canada, Mexico, Peru, Colombia, Jamaica, Guatemala, Ecuador, several countries in the Americas. And we chose for this project to work in El Salvador. El Salvador is in Central America. So the results of our study is published in this paper. And I'll briefly talk about this work. So this is the area that we work. It's in El Salvador. Here you can see Central America, and El Salvador is in this part here. Here a closer look at El Salvador, and here an even closer look of El Salvador. This is the country that we are going to work. So what was our objective? To understand the relationship among fire, rainfall, land use, and vegetation. Our question is, if we understand the occurrence of rainfall, land use, and vegetation, can we use this information to identify periods and areas of high risk of fire? This data was related to El Salvador, but occurrence of fire has been seen in other places. In Brazil, had increase in fires in some periods. Also in the United States, there were many losses caused by fire in the country. So this can be extended to other places. Now going to statistics. What we use the statistical tools to this work, to evaluate this relationship among these variables. We use it cross-correlation and lagged regression. The objective of the talk today is not to go into the statistical details, just show you the potential of statistics. So I'm not going to present the details of the techniques that you use, but just show you the main finding. Using those techniques, lagged regression and cross-correlation, we could identify that the main relation that we find was between fire, rainfall, and vegetation. And the main finding was that after 2 months of low levels of rainfall, it's observed reoccurrence of fire in low vegetation areas. So here you have some information of what for warnings. If we have low levels of rainfall, we should expect in around 2 months higher risks of fire. So we need to plan the city, the locations to try to avoid those fire occurrences. So like 2 months earlier, and also in areas that have low vegetation. So we need to work on these specific points. Another area that we worked in the context of the Fulbright project was regarding weather simulators. So to be better prepared to deal with extreme events related to weather and climate, we need to understand the relationships and do predictions and be able to model well the current situations to make good forecasting. And one tool that is used is weather simulators. And statistics can be used to evaluate the performance of those simulators. Here's the idea of a climate and weather simulation. They use global and regional models to describe the atmosphere. So here I'm concentrating on one specific model that is used, that's called the Weather Research and Forecasting. It's a contribution of different researchers. In Boulder, there is a National Center for Atmospheric Research, and they concentrate some of the researchers who helped most of the models for this model here. We have different areas that are part of this overall model. For example, how the land surface, how the cumulus, how the clouds, how they are formed, the shapes, radiation, surface layer, different steps of different phenomena that's related to the atmosphere, they are representing this model. So there are different configurations that one can use to make some forecasting. And it is based on differential equations. So researchers propose differential equations that will explain the nature, and these are embedded in this model. And this model has been used all over. This is a map of all the continents, and these are points on where countries that this model has been used, and has been increasing the number of users. And our objective is to improve the quality of climate and weather prediction. And one way of doing this is to use those models. But there is a challenge in this climate and weather modeling. So users, they have to specify a model configuration. They have different, say, small boxes with different phenomena in the atmosphere. And for each one, there are different models that are proposed for different researchers. And to choose one specific configuration, it's a task to the user. The model is available and the user has to specify which configuration it wants to use. And since it's been incorporated different contributions along the years, there are now millions of possible configurations. And different configurations may lead to very different results. Here you have a map of the Americas. And for example, we are looking at temperature, maximum temperature in the months of June, July, and August. And we have here 24 different configurations. Each map represents one different configuration. And the colors here represent the comparison with the observed values. We have the observed values, and we compare the observed values with the model values that are obtained from the weather model. So the ideal would be 0. That's the difference, would be 0. We'd like to see a map that would be all white. If it's going to the blue scale, it means that the model is underestimating the temperature. So the temperature from the model is lower than the observed temperatures. And if it's going to the red side, it's overestimating the temperature. So we can see that there are differences here. So this side here tends to underestimate, while this side here tends to overestimate. And you have, for example, this here that's almost white with some yellow lines here. So depending on the configuration, the results are different. And a user has the challenge. Which configuration should I use? And to answer this question is hard. One way is to use simulation like this to have test different configuration and see for a specific area which is the best configuration. And if you want to simulate a long period of time in a large area, just one simulation can take months. For example, to run this here, to have data to do this study, it took 6 months to get this data here. So it's not an easy task to do to identify the configuration. So now we can use experimentation to try to answer this question, to help this question. So statistical design experiments, it can be a controlled way to gather knowledge about complex systems, can help us to evaluate a large range of sources of uncertainty and compare different objectives. So the large increase in the number of limited area models shows the importance of comparing them. So we have a large number of possibilities. So we need to be able to understand the performance of all these configurations and try to find a good one for our objective. So we have an opportunity to plan, to execute, and analyze the data using design of experience. Let's see how we can do this. So in our project, our main contribution was this framework. We called it CSI's idea, like the Climate Statistics Investigation idea. It's an 8-step framework based on design of experience. So each letter of the CSI idea has a step that has to be executed, and it guides the practitioner to define its objective and how to choose a specific experiment, run the experiment, and analyze the experiment. We have specified conditions and explain each step and how it can be done. So with applying this framework, we can answer 2 main questions. What schemes can we use and why those schemes should be used? The current approach that is used in the area is based on these maps. They choose different sets of configurations and map all those configurations, and based on the appearance of the map, they choose the best configuration. But there is not a clear answer of why this configuration is the best. For example, looking at this picture, you can see that for all regions, this one seems to be a good configuration. But why is this the good configuration? So using a proper statistical analysis, we can identify why this is a good configuration. And also, we don't need to perform all configurations, all possible configurations, to identify the best configuration. Using statistics, we also can identify a good configuration without running all possible ones. So the objective of the proposed framework is to facilitate the understanding of the impact of physical parameterization on the performance of the weather and climate simulators, and guide the process of selecting appropriate schemes. I will show you one example that was done using the Americas. So this is our domain. The region is this part including part of South America, the whole Central America and North America, with 10 years of analysis from 1990 to 2000, and it's the resolution of the model. So we applied the 8-step framework. The first step is to identify the objective. We wanted to investigate the whole of parameterization, different parameterization schemes. The main variables, which was temperature maximum and minimum, and also tropical storms. And how can we evaluate those variables? We use the skill score, the difference that I mentioned. We have the observed values and the model values, and we evaluate the difference. We also evaluate the probability density functions and also the tails of the distribution, since you are interested in extreme events. So we analyze those metrics to understand the impact of the configurations in all those metrics. And we use some sources of uncertainty: radiation, cumulus, microphysics, planetary boundary layer. Those are those boxes that are the components of the overall weather model. So we want to understand what's the impact of each of those boxes, of each of those components. And then we use the resources. How many simulations can we use? It takes time and also computer memory. So to save, to store all those data, we need lots of storage. So based on the resources available, we need to identify how many simulations you can run, that you can execute based on the time it takes to get the data, and also be able to store those data. So based on those information, we can choose a specific design and also a specific model. I have been working with the weather and research forecasting model, but there are other models that are available that can be used that have a similar procedure. And then we can analyze the experiment. We propose to use most graphs to make it easier to identify the main results. So here is a summary of the results from this analysis. So I identified like 3 configurations that were good configurations to work with the variables that we are using. The temperature, tropical storm. So here are the configurations, identify what are the best configurations and why we use those configurations. One important point to say here is that depending on the variable and on the region, the configurations can change. So here we have those configurations for North and South America. The Central America, we couldn't get it. We could get other configurations that would be good for Central America. So these ones are some highlights for North and South America. Another study that we are doing that is a follow-up from this first study. This first study, they used all possible configurations. We're interested in 24 configurations, and we run an experiment with all 24. So it was our first experiment, and when I joined the team, they had already done the experiment. So I worked with the analysis of the experiment. So we could not use some statistical tools, some statistical experiments to try to decrease the number of possible configurations. So in this other study, so we are using this approach. So here, the total number of configurations that we are interested is 243 configurations. So we proposed an experiment that is going to run only 11 simulations. So
Dear
from
Carla,
okay,
sorry for interruption. Actually,
my
we
time
have
is
one
up.
more guest with us.
Okay.
Yes. Can you please wrap up?
So we just used 11 simulations to run. So we get some reduction. So this is our reference for this design. And I'll just go to the last one that I'd like to pose a question to the audience. Based on these studies, we are now having a challenge. We would like to work with rainfall and try to disaggregate the data. We have daily rainfall data. We would like to have information about hourly or even lesser data. So afterward, if the discussion has some time, I would like to ask you for cooperation to collaborate in this project. Thank you, and sorry for delaying the presentation. Thank you.
Thank you so much, Professor Carla, for a great presentation. Now I would invite our next speaker, Dr. Yaqub Ari. He will be presenting his lecture on an ARDL bounds test approach to urbanization, the case of Turkey. Dr. Yaqub has MBA in finance and PhD in economics and finance. He is presently serving as an assistant professor in the university, Alanya University, Alauddin Kakıbat University, Turkey. He has worked as a statistical consultant in different private companies in Istanbul. His areas of research are statistics, biostatistics, and econometrics. Over to you, Dr. Ari.
Hi, everyone. Can you hear me? Can you hear me?
Yes.
Yes, we
Okay.
can.
Yes, we can.
Okay. First of all, I would like to thank you to the organizers to give me this opportunity. My talk is about autoregressive distributed bounds test approach to the urbanization. I use the Turkish data as an example for this approach. My outline of the presentation is including a brief introduction, then details in methodology, and real data application with Turkish data, and brief conclusion. As you know, urbanization is one of the important indicators of change, especially in developing and modernizing societies. The factors that cause urbanization can generally be listed as economic, political, technological, and socio-political reasons. Socio-political and economic advantages offered by the cities are more than the rural areas. And however, unplanned urbanization causes many problems in societies that have not fully reached the stage of being an industrial society and have not completed the modernization process. Therefore, statistical approaches are gaining importance in the measurement of the relationship between urbanization tools and other parameters in studies in this area. Urbanization has accelerated after 50s in Turkey. However, migration in the country accelerated urbanization more after 98. In 1980, the adoption of more liberal policies instead of mixed economic policies and the sale of state-of economic enterprises, privatization led to acceleration of this process. Today, it is known that 75.6% of the population living in urban areas in Turkey. Although this situation is mostly explained for economic reasons, the effect of political and socio-political reasons cannot be denied. let us look at the graph of the urbanization rates in Turkey and European Union and the world. As it is seen in the graph, after especially 1968, the urbanization rate in Turkey has exceeded the global average. And now it is approaching the European Union average. This rapid urbanization brought many problems due to the fact that the industrialization rate is lower than the urbanization rate in Turkey. The poverty of the rural population is carried to the cities. Moreover, the low industrialization rate cannot create sufficient employment opportunities in Turkey nowadays. Therefore, with urbanization, new employment problems arise. Today, unemployment rate is in Turkey over 15%. Aim of this study is focusing on the variables, economic and demographic variables that are includes urbanization rate, economic growth, employment rate, and inflation rate. The main objective of this study to reveal the short-run and long-run relationships between the mentioned variables. Moreover, it is an example of a statistical approach that can be used in urbanization studies. For this purpose, autoregressive distributed lag balance test, which is introduced by Pesant and his colleagues, Sheen and Professor Ron Smith. This approach is used to reveal cointegration between variables. I don't want to take your time, and this is the literature that that examined urbanization studies, especially urbanization in Turkey is the subject of these works. I skipped this part, and I want to talk about methodology in details. This is a flow chart. As you see, this flow chart doesn't include most of the time series models, especially the volatility models, GARCH and its extensions, because I create this chart to show which models evaluate the cointegration between the variables. When using the linear time series methods, it is an important issue to determine the stationary level of the variables in order to avoid the spurious regression problem. In this context, we can construct an algorithm in general. It is a general approach. If all variables are stationary at levels or integrated to zero, one can apply ordinal least square or vector autoregressive models. If all variables are different stationary, integrated one, if one can apply the cointegration methods, following cointegration method: Engel-Granger cointegration, Philip-Euler's cointegration, Johansson and Johansson-Husserl's cointegration methods. These all These all methods produce consistent results when the variables are integrated in the same order. If the variables are stationary at different levels, some of them integrated stationary at level or different stationary at the first difference, one can apply ARDL bounds testing. Compared with traditional linear time series methods, the ARDL approach can be used even if the variables are stationary at different levels. We can see. In addition, it has important advantages, such as achieving statistically significant results in small samples, being suitable for the examination of short-run and long-run relationships together, and being practical in reaching the error correction model. Then we can state general ARDL model as given in equation 1. As you see, U sub t is error term with 0 mean. Xt is vector of k-dimensional vector of experimental variables, and y sub t is the lag values of the dependent variable. The usual ARDL method is based on the standard least square regression methods, in which the lag values of both dependent variable and the experimental variable are used as the experimental variable. In our study, we use the variables unemployment rate, urbanization rate, economics, GDP growth, and inflation rate. Using these variables, ARDL model can be constructed as in equation 2. As you see, there are terms theta sub 0 and theta sub 1 t. It is deterministic dynamics which show the constant and the trend in the equation. The alpha coefficients represent the short run dynamics. The other beta coefficients they show the long run dynamics in the model. So we can say in ARDL approach of Pesaran, Shin, and Smith, the model is constructed with two parts. These parts are short run and long run dynamics, respectively. Now, this flow chart for the bounds test approach, with starting with the unit root test. We should apply the unit root test to ensure all variables are integrated of order less than 1, because the bounds test approach works when the variables are integrated 0 or integrated 1. If all variables are level stationary or difference stationary, first difference stationary, we can specify which deterministic dynamics enter the model. we specify this this deterministic part because data generating process depends on it. Then we we can determine the optimal lag lengths for the model using the usual information criteria, such as Bayesian information criteria or Schwarz information criteria. Then we can estimate the model. After estimating model, we have to apply the diagnostic test to ensure the residuals of the model uncorrelated and homoscedastic. If residuals are serially correlated or heteroscedastic, we can increase the legs of the model, and we can apply different parameter estimation methods such as white or heteroscedastic AC covariance matrix. We usually use the diagnostic test to ensure that we use the Broch-Pagan-Gottfried heteroscedastic test and Broch-Gottfried serial correlation test to ensure the residuals of the model uncorrelated and homoscedastic. And in addition, there are some diagnostic tests, such as Jacques-Perret normality test to measure the distribution of the error terms, and some stable tests, such as a Ramsey reset test, QSUM, and QSUM square tests to state stability of the model. If residuals are serially uncorrelated and homoscedastic, we can apply a bounce test. When we perform the bounce test, the null hypothesis is the test is sorry. Null hypothesis of the test is beta coefficients are equal to 0 to test with the alternative hypothesis. At least one of the beta coefficients is different from 0. In the paper of Pesara, they calculate the critical values for this bounce test, but the sample size is asymptotically 1,000. As you know, in real life, sample sizes are too small in the studies. Because of that, Narayan, the study of Narayan in 2005, he calculated new critical values for sample sizes ranging from 30 to 8. So after the F bounce test, you should consider the sample size to decide to reject the null hypothesis. The next step is if the null hypothesis is rejected, null hypothesis of the advanced test is rejected, one can run the t-test to identify the alternative hypothesis. These alternative hypotheses are there can be nonsensical relationship between variables, or cointegrating relationship is standard and it does indeed exist, or cointegrating relationship is degenerate. If the t-test results accept the alternative, reject the null hypothesis, there is a cointegration relationship and it is standard. So we can apply error correction approach to estimate speed of adjustments between the variables. In our case, before passing the case, there are 5 data generating processes in this approach. These are depends on including constant or trend. Usually in the applications.
Excuse me, Yakub, we have another guest with us and we have just 30 minutes. So would you like to wind it up? Thank you.
Okay. Thank you. Okay. So I skip this part, and if you would like to know the details for these studies, one can see the following papers, including log operator calculation using Beveridge-Nelson decompositions. These are the references. And real data application, I applied the data period between 1980 to 2019. I skipped the descriptive statistics. This is the first step of the approach, unit root test. I used the flip speron and augmented diffuser. So the variables have different levels of stationary. Our dependent variable unemployment rate is first difference stationary. This is the model selection of ideal. Then I construct a conditional error correction model. This is the results of the bounce test. As you see, the f-statistics of Pesaran is equal to 8.60. It is greater than any of level greater than any critical value determined for the any confidence interval from 10% to 1. But we have to use the NARAM critical values. It is because the sample size is 38. If you compare the f-statistic value with the critical values, there is a integration between variables. To satisfy the robustness of this conclusion, we should apply, we should check the t statistics value, and it is significant at 5%. So we can conclude that there is a long-run relationship between variables. There is a integration, and it is indeed X. This is the long-run regression output. You can see the effect of the dependent variables on independent variables on the dependent variable. Inflation rates and GDP growth rates has a significant effect on the employment rate. Then the last is the error correction model to determine the speed of adjustment. In this case, the adjustment speed is found 44%. This implies when disequilibrium occurs between the variables, it adjusts after 2.26 years. And I skipped the diagnostic text. All diagnostics show that model is the most convenient model to evaluate the integration. Conclusion, we can say every scientific study on the country's economy, on the Turkey's economy, has become priority for policymakers because nowadays Turkey has high short-run foreign debts, and the unemployment rate is increasing every month. And one of the most country has high inflation in the world, Turkey. For the so we can extend this study using different variables, also including the dummy variable, which shows the COVID-19 period. Thank you. That's all.
Thank you so much, Dr. Yaqub, for presenting your study, for sharing your study with us, with LISA 2020 Network. Thank you for joining us today. Now I will move to our next guest, speaker. He is Professor Agubiade. He will present his talk on urban planning and geospatial statistics. He is from University of Lagos. He is senior lecturer in the Department of Urban and Regional Planning. Mr. Agubiade has specialities in geospatial data, urban planning, infrastructure, urban governance, housing, and land. Over to you, Dr. Agubiade.
Yeah, good day, everyone. I hope you can hear me clearly, and I hope you can see my screen. Someone to just confirm, please.
Yes, we can see. We can see.
Can you all hear me clearly?
Yes, we can hear you.
Okay.
We can hear you.
Thank you very much. Yeah, on behalf of my group, LISA group, I want to thank the organizers for this opportunity to present some of our work to the larger audience. The title today is Urban Planning and Geospatial Statistics. The presentation is arranged in three introduction, where we'll be discussing the conceptual issues, and then which will lead to some key questions. And then the second clusters will be on data analytics, where we'll be talking about big data, PIM, Twin City, and that. And then the third clusters will be how do we bring all these things together in terms of understanding the nexus between urban planning and geospatial statistics. Conceptual issues. Most times there is always this tension between or trying to discuss what exactly is planning. And there's so many nomenclature or so many types choose to describe it as land use, others as urban planning, some other as physical planning. But whatever is the definition, I want to describe it as focusing on the location of uses, efficient location of uses, and allocation of spaces. So, and it's one of the very critical aspects of land management. So, I want to take us through briefly what do you mean by land management. It generally involves and it requires interdisciplinary skills based on some technical and natural or social science skills. And it's all about understanding the country context in terms of the institutional arrangements within a particular jurisdiction. It's about land policies within that jurisdiction. And most importantly, it's about land information. So we'll be dwelling more on these aspects today, the link between land administration and land use as how it affects sustainable development. So we want to also focus more on land administration. Like I said, the first one, the critical thing is the land information infrastructure, which is data. So there is no way we'll talk about land use planning or physical planning, as the case may be, without dwelling extensively on data, which is the engine that powers it. So, and the quality of planning we do is a function of the quality of data, and the quality of data is a function of the quality of analysis and possibly the application of appropriate statistical tools that will make all these things happen. So you rely on data to get good policy and good planning before we can talk of sustainable development. So land use, spatial planning or physical planning, as the case might be, requires application of some planning processes, meaning that we have to go through the process of data collection, data processing, and data analysis. For urban planning to play this role, it has to rely on adequate spatial data sets. Now, geospatial statistics is just an aspect of statistics, but I can argue that it's actually a very broad aspect of statistics, which then encompasses other elements, other components of statistics, because it is peculiar to, you have to take into consideration the spatial dimension or location of the data sets for all the decisions that are made, and this has a wide-ranging implications for sustainable development. So quickly, let us go to geospatial statistics. Just the analysis of any kind of the formal techniques which study entities using topological, geometrical, and geographical properties. So if the data set lacks any of these components, then it's going to create problem for our analysis. And if our analysis has problem, then there will be problem when it comes to planning. And when we get it wrong, like the first presenter showed us, then we have longer implication for the entire environment in terms of the implication for the spatial space. So the three components of geospatial statistics are topology, which serve as a description of how features are spatially related these features generally are located, are represented geographically using 3 primitives. We use point, we use line, and we use polygon. And this, the way the data base is structured will allow us to determine the level of the analysis that you can perform on it. Topology enables your database to more accurately model geometrical relationships. So the specific thing we are emphasizing here that is peculiar to geospatial statistics is about the relationship of features within space. House A is located relative to house B, then the distance to B is this. So all these are very important for us to be able to make informed decisions. So the second component is the geometry, which concerns the properties of the space and which relate to distance, shape, size, and the relative position. And then the basic geometrical concepts are dependent on those 3 primitives I mentioned earlier. This refers to the mark on the position of the accurate location. That means any features that is represented in our database must have the X and Y coordinates in the technical sense of it, so that you can actually locate that feature. And then the third component is the geographical properties. Again, it has to do with location, where is what, where is X and Y. So we have to bring location into our statistics. So it's not enough to have huge data sets, size or strata or whatever format, but we should be able to then be able to do this kind of analysis, proximity analysis. What is the size, what is the adjacency, connectivity, containment, and pattern can then clearly emerge from our statistical analysis. So to summarize this section, the first section, I said planning is about people, it's about places, and places in virtual world is places in the conventional sense of it, then spaces in the virtual sense of it, where you can relate with that location in the virtual world, and then how the people and places are combined to make maps. And then the statistics deal with the numbers, patterns, and inferences that we can clearly see from our data sets. So through geospatial statistical analysis, it enables us to adequately and sustainably connect people to places in order to have efficient planning. So the key questions. We are aware of the complexity. So how will developing nations cope or adjust to these different dimensions, especially the real-time data analysis and processing? How can the big data be adequately interrogated? How can it be harmonized? And how can it be aggregated for decision making? And how can we use our artificial intelligence and data analytics to rescue the spatial dimension of our virtual world, which what we refer to in the present layer as twin city, meaning that you are cloning the physical world in the virtual world to be able to replicate it and then be able to deal with it. So the present day reality, we are confronted with the complexity of urbanization. So we have spaces that has no boundary now, has no limit. Cities now do not have borders. Then to adequately create 3D or 2D or virtual reality, meaning that we have to find way of integrating different components of our data sets. So the key issue, is the place. Someone is distracting us.
Your video on the platform.
Please, participants, mute your mic, please. I think.
So
please mute your mics, participants. We have presentation going on.
So the key issues here will be where is the place of big data. Now we initially, in the traditional sense, statistics about data collection, design questionnaire, we interview people and all that. These days we rely on VIG, where people through the internet, through Google, through other devices, get so many data coming in. There are instances where you install Internet of Things, camera, network of cameras, sensors, and all that. And meaning that all the information is coming from all these different channels. How do you bring them together? How do you then make sense out of it? And how then do we use it to make informed decisions? So that is where the issue of data science comes into play, which it combines multiple fields and it refers to overlapping area of statistics and methods and data analysis, all of which are used to extract meanings and insights from data. So quickly, let us go through a case study that relates to urban analytics. We participated in a project called Urban Analysis, UADI. The whole essence of the objective of that project is to provide an underlying framework for harmonizing and integrating urban data. And you are aware at a point there is a need for us to assess SDG goals. And then we realize that the way some of these targets and goals are set in different jurisdictions are different. So we need to come up with an algorithm that will identify different composition of data sets and components of data sets for us to be able to make informed decisions. For instance, if you say density in Lagos, is it described the same way in Brazil? So the issue of ontology and semantics comes into this. So bring out the whole idea of the project is to bring all these things together using semantics and ontology to bring different data sets from different sources to the extent that we are comparing apple for apple. So if you say we have, for instance, if you say there is a decision in Lagos, is it the same parameter we use in Lagos that we use in Brazil? In Australia, for instance, if you are more than two in a room, it's considered that the room is congested. In Lagos, we have more than, for instance, you have 7 people, 8 people. The definition of congestion in Lagos is if you have different sexes, I mean male and female, it doesn't matter how many of them, but the moment that if you can achieve the situation that they are not living together, then you can have more than 2 in a room and still will not be considered as being congested. So these are the parameters you have to look to develop data tools and to develop a platform for integration of this data set. I want to quickly skip some of these things so that I can discuss the other ones. So the third cluster is about bringing all these things together. And then why do we bring planning and geospatial statistics together? Data science is a subset of artificial intelligence. And it's more to the developing area of statistics. Whereas statistics is about mathematical science pertaining to the collection, analysis, and interpretation to bring down trend and pattern. Meanwhile, physical planning is to organize land uses. So how do we bring all these 3 things together? So that will take us to the second case. Now, one of the major challenges we have, especially in most developing countries, is to be able to accurately estimate our population. This has been a major problem for us in Nigeria, given the fact that it's really expensive to do. Beyond the expenses, there are a lot of political consideration, and then which most times will not make us to accept the outcome of most of these sensors. So we then thought of what should be another alternative to estimating population that will give us very near estimate of the population. So that was what we then used a grade 3 data set, and there is this specific application to determine the accuracy of population on 1 square kilometer density plotting of, determining the density of population in each geography. And then using remote sensing technology and GIS, as well as artificial intelligence, we're able to bring together the determining that these are the steps that you follow. Determining microsensors, that is collection of microsensors at randomly selected areas. Then geospatial covariate data sets of areas, so that we can then determine some parameters, household size, population estimate, settlement type, pattern, and all that. Then using machine learning model to interrogate this, and then combining that with algorithm of hierarchical Bayesian regression. So we're able to, with this combination of these different styles or method, and using this the Bayesian positioning, we're able to determine population density for 1 square kilometer, meaning that you can actually aggregate this to any level, any type of geography. Will it maybe ward level, district level, local government level, state level, or even at national level? This is kind of outputs that was generated through that approach. Another case study where we combine different methods to achieve specific tasks is the application of a multi-criteria decision model. And I also participated in a project where we were trying to estimate residential potential index in some central city area in some developing country as well as developed countries. The whole idea is we have to take into consideration several multiple layers of variables. For instance, location of public transport system, public facilities. The whole idea is to determine the value of land relative to the value of improvement on land, and be able to determine what areas have more potential for regeneration of urban decaying area. So we're able to do that, and we're able to map that. Currently, the last application case we are dealing with is to determine the application of hierarchical spatial reasoning
Sorry, Agubiade. We have just 5 minutes to end this session.
Lagos. We
are running out of time. Can you please wind it up?
So we use hierarchical spatial reasoning to map out address system to develop a workable postcode system for Nigeria. So this is the kind of output we're thinking we can generate when we combine different levels of hierarchies to generate different postcodes to deal with navigation, to deal with commerce, to deal with so many other urban development. Thank you very much.
Thank you, Professor Agubiade. It was really excellent presentation. Although we couldn't give you enough time to present your work, but it was an excellent research. And I'm sorry for that, it happens in online sessions. So with that, I would ask participants to ask questions from the speakers of today's session. If they have any question, they can ask. Yes. Is there any question, participants, you would like to ask from our guest speakers? We had 3 presentations today, one by Professor Carla, the second was by Professor Yaqub, and the third by Professor Agubiade. Yes. I can take 3 questions. Yes, anyone?
If you permit me, can I go on with my question?
Oh, yes, sure, please.
Okay, thank you so much. My question will be directed to Professor Agubiade. That's a very interesting presentation. Thank you for your presentation. And it's actually thought-provoking. Yes, regarding this gathering geospatial data, I want to check with you. Take, for example, now that I want to cover a particular place, a particular area in Ile-Ife. Ile-Ife is located about 100 kilometers away from Ibadan. I just want to create a particular section of Ile-Ife, for example, and then maybe we have 4 local governments in Ile-Ife, and I'm interested in capturing the population using geospatial data, population of people. I want to know the concentration of people using geospatial data. Do we have the data of Ile-Ife, for example, or any part of Ibadan, or any part of Lagos stored somewhere where we can harvest? Or is there any provision for us to possibly through Google Map to see how that can be harvested or snapped at a point in time? So that's my first question. And then my second question is, how do we then harvest the data points into a CSV for machine learning activity, machine learning analysis? These are my first few questions.
Can I respond to that, moderator?
Oh, yes, please.
Yeah, thank you for your question. Yes, you have a population estimates computed through grid 3 for the entire country. I mean, it's not only Nigeria alone. I think there are about 400 or 500 countries in Africa that are included in this project. The only issue you might have is the ability to extract the areas that you need. And that is exactly what I said we have developed with my research group at University of Lagos. So we welcome you on board if you want to join us in exploring this. We can share the code that was written in Python to extract the relevant section. Yeah, to extract the relevant section of it, so that you can then use it for your particular or targeted research.
Oh, okay.
I think that is what you want, and
yes,
we have done that, and we can share that with you. Yeah.
Oh, that's very lovely. So that means the data is not publicly available for now.
It's publicly available, and you have it in CSV and you have it in ArcGIS. But
okay, is it online?
It's online, yes.
Anywhere? Oh, I would like to
it's
have
online.
Information about it.
I will share get my email address then, so that we don't waste other people's, so that we can discuss this further.
Okay,
it's online, but the few lines of code that you write to extract it, we can share that with you.
Oh, thank you so much. Thank you, Prof.
Yeah.
Anybody else who would like to ask question from our presenters? Yes. I would really appreciate if you ask a question from any of the presenters, Professor Carla and Dr. Yaqub. Dr. Yaqub, I have a question from you. In your presentation, you have shown that urbanization doesn't have significant impact. By significant, I mean statistically significant impact on the unemployment in Turkey.
Yes.
So would you please tell us that what are the reasons why that effect is not significant in Turkey?
Sorry?
In your presentation, you showed
Yes.
that your research showed that.
Yeah, urbanization has a significant effect on unemployment.
Yes, urbanization does not have significant effect. It means the relationship was not statistically significant between unemployment and urbanization. My question is that what are the reasons behind it? Because this is something which is interesting to know.
I think, you know, the population of Turkey is over 80 million, and most of the people lives in big cities, and big cities give opportunity to people, a lot of work opportunities. When the urbanization rates is increasing. So unemployment rates probably decrease. But it is
Yes, I carried it. I carried it.
it is
I carried it back. I brought it back.
significant when the confidence level is 10%. In this study show.
No, that one, you know, that's a good one. I don't know. Anyway,
It is statistically significant when the confidence level is 10% in the long run. But in the short run, there is a significant relationship between urbanization and unemployment, and there is a balance between these variables. Maybe if we apply this methodology to monthly data, you know, the data was annual data. Maybe it can be changed.
Thank you, Yakub, Dr. Yakub. So we have another question for Professor Ogunbiade, and that question is from Yami. That can you kindly clarify the twin city concept mentioned in your presentation?
Okay, thank you for that question. What is twin city? It's just a dynamic, data-driven, multi-dimensional digital replica of physical entity. I will explain, break it down. What it means is you have the data set, you have the model, and you have the visualization. What digital twin city is trying to create is to have a clone of real life situation in. It's like you have a local government you can put in a drawer and just pull out the drawer and just through virtual reality and augmented reality, walk through it as if you're actually within, without leaving your room or your office. You have the feel that you're actually within the local government. And that is done by network of different sensors, network of cameras, and then Internet of Things, that to the extent that everything is being processed real time, so that you can imagine as if you are actually in the virtual world, but you are feeling the physical world. So that's why it's make it twin. It's a twin of the real life situation and virtual world. And what is driving is data, huge data set with powerful algorithm for it to work, to be able to do real-time analysis and real-time processing. And that is essentially the concept of twin city.
Thank you, Ogunbiade. My question is from Professor Carla, if she is here. Carla, can you hear me?
Yes, I'm here.
Okay. So in your presentation, you talked about the design of experimentation. My question is that its application seems limited in modeling the climate change data. So what are the challenges in using design of experimentation? Why its application is so limited?
I think that's because of the lack of collaboration with statisticians and the research in the climate area. We have recent papers talking about that, and they are trying to increase this collaboration. There are some use of design of experiments in this area, but they use very basic designs. So they do not explore the potential of design of experiments. That's what our work intends to do, to explore other different types of experimental design that can bring benefits to this area. One main issue is the large quantity of objects to be compared, like millions of them. So if you plan an experiment, well-designed experiments, you can get information from a large range of configurations without running or getting data from all possible configurations.
That's great. Thank you so much for answering this question. So if you don't have any question, audience, so we can end this session. And at the end, I would like to say thanks to Professor Arik for organizing this session, and Professor Olewule. Without his coordination, I know that I would have never been able to arrange such a good session for all of you. And I would also like to say thanks to Tanuki, my dear friend, and all these speakers, especially Professor Carla, Yakub, and Agumbiade. And with that, I wish you a very good life. Take care of yourself. And I also would like to say thanks to all the participants. Without them, we cannot have this wonderful session. So with this, I would like to say bye-bye to all of you, and hope to meet you again. Thank you so much. Thank you so much.
Thank you.
Thank
Thank
you.
you.
Thanks, everyone.
Thank you.
Thanks, everyone.
Thank you so much.
See you.
Bye, everyone.
Bye.
Bye, everyone. See you again. Professor, where please call me.
All right. All right.